Fowler Trimos Labconcept Nano is our most accurate gauge to date.
It features 3 application ranges, 14-inch, 24-inch, and 44-inch, and a max error at full measuring range of 0.245 microns, or 9.6 microinches. The Nano's resolution is 0.1 microinches, or 1 nanometer, and is repeatable to 0.03 microns, or 1.2 microinches.
In this video, we will outline some of the most common measuring applications. This gauge offers 3-axis CNC motion control. The Z and Y axes are actuated from within the measuring table. The X-axis carriage moves along the beam to apply an adjustable and consistent measuring force. For external diameters, a preload is first applied. The part is then swept in the Y direction to find the reversal point. Inside diameters larger than 1/2 of an inch may be measured with the L-shaped probe attachments. The process is nearly identical to that for the outside diameters. Inside diameters too small for the L-shaped attachments can be accessed using a ruby ball probe attached to the internal measuring device. Here, a straight bore master ring is being measured by a ruby ball probe. You can see the left side reading being taken. The machine then reverses and sweeps for the center point on the opposite wall. Thread plugs could be measured with thread wires, shown here in dedicated holders. The associated gauge management software, QMsoft, maintains a database of the available wire diameters. It will select the proper wire diameter to use for a given thread pitch. Internal thread rings are a simple matter with the Labconcept Nano. For this application, the internal measuring device is outfitted with a T-shaped ruby ball probe. As with the thread wires, QMsoft holds a database of available probe ball diameters. The probe will sweep for a reversal point, then repeat the motion on the next thread down. To complete the measurement, this action is then performed on the opposing ring wall. This 3-point method can be used on straight or tapered thread rings.
In addition to the pre-programmed measuring modes, the machine can also be manipulated manually through use of the mouse, touchscreen, or alternatively, with joystick. And now for some of the features of the software.
Up here in the top left corner is the main WinDHI interface. This has your basic controls, minimum maximum buttons, presets, units, and references. On the bottom left, you see the control screen for the motorized axes, including automated measuring sequences. On the right is WinComp, which monitors and compensates for fluctuations in temperature. Here it displays the temperature of the scale and the workpiece via a magnetic thermal probe. This program also graphs temperature data over time. It can be set up to send alerts if the lab temperature goes outside of required bounds.